All right, let's look at polynomial and rational inequalities. This first example is a polynomial, is a quadratic, and we're looking at when is this function x squared minus 6x plus 5, when is that less than 0? And we can look at the graph. It's less than 0 when down in here in this section of the graph when the output is negative. All right, so that is here. Now the answer to our inequality is which x values correspond to that section of the graph. And so we just would look, because it's only less than, we're just taking this little interval right in here. So it goes between 1 and 5. And then if we have less than and also equal to, it would be the same interval, but we can include the 1 and the 5. And now we're looking at when is this function greater than 0, so when is its output positive? There's two places, so we need to look at both of those. All right, we've got the first section, it's positive back here, so any x that goes from negative infinity up until we get to that 1. All right, so we're going from negative infinity to 1, not including it. And then the other section would be over on the other side from 5 to infinity. And then if it's also including, then it's just the same intervals except we get to include the 1 and we get to include the 5. So that's our other section is right over here. Great. All right, I am going to move everything to the left side. That's my first step. Then I'm going to factor. And then we look for key points, which are the x-intercepts. Then I'll check the sign on each interval, and then I'll be able to solve this. Okay, so I'm going to move everything over to the other side. So subtract 4x squared, bring that over, and add 4 to both sides. So I've got x cubed minus 4x squared minus x plus 4 is greater than or equal to 0. Next step is to factor, and since I have 4 terms, I'm going to try factoring by grouping. In this first little group, it looks like I can factor out an x squared, so I would get x minus 4, and then I'm going to factor out a negative 1 and get x minus 4. And then I can factor out that entire x minus 4 term, so out that comes, and I'm left with x squared minus 1. X squared minus 1. And then I can still factor because that is a difference of perfect squares. X squared minus 1 factors as x plus 1 and then x minus 1. Okay, so this is my function right here. All of this is my function, and I'm looking for when is the function greater than or equal to 0. So I need positive output. Okay, so that's the first step, or the first two. Move everything to the left and factor. Now okay, next step is to come up with what are the key points. And for a polynomial inequality, that is when the output is 0. Those are the x-intercepts. Okay, so I would take x minus 4, x plus 1, x minus 1 and set that equal to 0, and then 0 product property gives me that x equals a positive 4, a negative 1, and a positive 1. So those are our key points. All right, and I'm going to have, so negative 1, 1, and 4. So now I'm going to test some points that these are when it's actually equal to 0 here. So there's my x-intercepts. But I want to test some points to see the sign in each of those other intervals. So I'm going to test points that are not those particular ones. So it looks like anything in between there. I'm just going to choose nice and easy numbers, maybe 5. All right, now I'm going to look at each of the factors of my function, so x minus 4, x plus 1, and x minus 1. And I just need to do a little mental math and just think about what's the sign in of the output. And then I can combine all that together to figure out the sign of my function. So if I plugged in -2 in here, I'd get -2 minus 4. And I don't care about the actual number, I just want to know what's the sign of that, which is negative. All right, and then if I put in a -2, -2 plus 1, that's still negative. -2 minus 1, that's negative. Now the function is the product of each of these factors. So I have a negative times a negative is positive, times another negative. That output is negative. Let's try another one. Okay, 0 minus 4, that's negative. 0 plus 1, that's positive. And 0 minus 1, that's negative. Okay, the function is just multiply those outputs together. Negative times positive times negative. That output would be positive. We don't care about the actual number, just the sign, because our question is looking at when is this function positive. It doesn't care about what the actual value is, it's just when is it positive. Moving on, 2 minus 4, that's negative. 2 plus 1, that's positive. 2 minus 1, that is positive. Negative times positive is negative. One more. 5 minus 4, that is positive. 5 plus 1, positive. 5 minus 1, positive. So the sum of each of those is positive. And now to answer my final question here, I'm going to put it all together right in here and solve that inequality. When is the output positive? Well, right here and right here. Okay, so those are the positive intervals, and then because I have this equal sign there as well, I can include the places where it's actually equal to 0. So the answer is, what's the interval? What are all the x's that make this true? And those x's go from -1, this was a positive 1, so -1 to 1, or over here from 4 to infinity. And that's my answer. And I graphed our function for us just so we can see. And you can see that the function is positive in these intervals. Here from -1 to 1, and then also from positive 4 on off towards infinity for any x value. All right. Done and done. Put in, when we have a rational function, it is similar where you need to move everything to the left side and factor. The only difference is that our key points here, we also need to look at when is the function undefined. So we'll just need to add that one step. So let me show you how to do this. Factor the numerator, I would get 2 times x squared minus 2. And factoring the denominator, I would get x minus 4 times x plus 1, and that's all less than 0. Okay, so I did the first two steps. Everything's on the left side, and I factored. Now I need to find my key points. So just like polynomial functions, one of the areas with key points is when my output is 0. And so those are those x-axis, or those x-intercepts. When is this 0? Here's my function, x minus 4, x plus 1. Set that equal to 0. And then you can see if I clear fractions here, it's really just when is the numerator equal to 0. And so solving that, I'd get x squared minus 2 equals 0. Add 2 to both sides. X squared equals 2, so x equals the positive or negative square root of 2. So x is about 1.4 or negative 1.4. Now another place where I have key points is where f of x is undefined. And that is when the denominator is equal to 0. So x, here, let's see, I had already factored that denominator, x minus 4, x plus 1. When is that equal to 0? And that happens when x is equal to 4 or x is equal to -1. Okay, now that I have my key points, now the next thing is to try and test my intervals and figure out the sign there. So let's see, negative 1.4, and then I go to negative 1, and then I go to positive 1.4, and then I go to 4. So just put those in order. And now we want to test some nice easy points in those intervals. So how about negative 2, and I'm just going to try negative 1.1 and 0, and how about 2? Just find the easiest point you can in those intervals. Now I look at every piece of my function. So I have the numerator 2 times x squared minus 2, and I have x minus 4 in the denominator and also x plus 1 in the denominator. Okay, so my function takes that, it's going to be the sign of the numerator divided by the sign of the sum of the denominators, those factors. Okay, so now let's see here. In those intervals, oh, I also need to try something out here on the other side of 4. Okay, so when I take negative 2 and I square it, that's a positive 4. Subtracting 2 gives me a positive number, so that ends up being positive. And now negative 2 minus 4, that's negative. Negative 2 plus 1 is negative. So my denominator is these I would multiply. This is my denominator. Negative times negative is positive, and then my function takes numerator divided by denominator. So the total output there is positive. Negative 1.1. I square that and I get 1.21 positive. 1.21 minus 2, that's negative. And if I double that, it's still negative. Negative 1.1 minus 4, that's negative, and negative 1.1 plus 1 is negative. Multiply the factors in my denominator, I get a positive number. And so then I have a negative divided by a positive, that gives me a negative output. All right, 0. 0 squared minus 2, that's negative. 0 minus 4 is negative. 0 plus 1 is positive. So my denominator here ends up being negative, and then I have a negative divided by a negative. That is a positive. Okay, for 2, 2 squared is 4. 4 minus 2 is positive. Multiplied by 2, it's still positive. 2 minus 4 is negative. 2 plus 1 is positive. So output there is negative. And 5 gives me a positive output for all of those. Okay, and then we go back and look at, well, what was the question actually asking me? Right in here. When is my output negative? Oh. So I have a negative in here. Let's see, the undefined was at negative 1 and 4. And let's see, negative is right in here as well. So those are my outputs, which are negative. And so I have 2 intervals. I'm going from negative 4, whoops, not including it. That should just be a parentheses. Negative 4 to negative 1. And then from 1.4 on towards infinity. And those are the square roots of 2. So it'd be negative square root of 2, and this is positive square root of 2. So putting that together, my final answer here is I'm going from negative square root of 2 to negative 1, and then there's the other interval from positive square root of 2 to 4. So there's my final answer, and then I did graph this for us, so we can just double check. Yeah, and you can see here that I've got negative output in 2 sections of the graph. Right here heading towards that asymptote, and then this little section right in here as well.